Hi everyone. Today we'll talk about limits of piecewise-defined functions. To be able to talk about limits of such functions, we have to first understand what they are. So, let's start with a quick exercise. I give you a piecewise-defined function, and I ask you to find the values of that function at 5 different inputs. If you would like to try this exercise on your own first, you can download these notes using the link in the video description. Sometimes functions have one formula. Sometimes functions have more than one formula. Piecewise-defined functions are functions that have more than one formula. For example, this function has 2 formulas. Negative x minus 2, you use that formula for x is less than 1. And you use 3x plus 1 for x is bigger or equal to 1. If you want to compute the value of this function at negative 3, you know that the input negative 3 is less than 1. So you are going to use the top formula. You will plug in negative 3 instead of that x, and you will get minus negative 3 minus 2. That gives you 3 minus 2, which is 1. If you plug in 0, you use the same formula because 0 is less than 1. Negative 0 minus 2 just gives you negative 2. When you plug in 0.9, again you use the top formula because 0.9 is less than 1. Negative 0.9 minus 2 is negative 2.9. When you want to plug in 1, you will have to use the bottom formula because 1 is bigger or equal to 1. So plugging 1 to the bottom expression gives you 3 times 1 plus 1, which is 4. To plug in 2, again you use the bottom formula. You get 3 times 2 plus 1, which gives you 7. Now that we understand how to compute values of piecewise-defined functions, we can try to compute limits of piecewise-defined functions. I give you a piecewise-defined function here, and I want you to find the limit as x approaches 1 from the left, as x approaches 1 from the right, and as x goes to 1. If you would like to try this exercise on your own first, you can stop the video now. To compute the limit as x approaches 1 from the left, I will use inputs that are less than 1. So inputs such as 0.9, 0.99, 0.999, and so on. All those inputs are less than 1. So to compute the limit from the left, I will use the formula for x is less than 1, which is negative x minus 2. So to compute the limit of this function as x goes to 1 from the left is to compute the limit of the top formula. Now I apply the direct substitution property. I plug in 1 and I get negative 1 minus 2, which gives me negative 3. To compute the limit from the right, I'm using x's bigger than 1, such as 1.1, 1.01, 1.001. All those x's are bigger than 1, so I'm using the bottom formula. So to compute this limit, I take the limit as x goes to 1 from the right of the bottom formula, which is 3x plus 1. I apply the direct substitution property, plug in 1, I get 3 times 1 plus 1, which gives me 4. I see that the left-hand limit was negative 3. The right-hand limit is 4. Because those two limits are not the same, the general limit does not exist. I have one more exercise to try. If you would like to try it on your own first, again, this is a good time to stop the video. We must find the limit of this piecewise-defined function as x approaches 4 from the left, as x approaches 4 from the right, and the general limit at 4. Let's start with the limit as x approaches 4 from the left. This function looks complicated, but if you keep your cool, I believe you can handle it. I look at 4 from the left, which means I'm using numbers less than 4, the inputs less than 4. Inputs less than 4 use the top formula. So that means to compute the limit from the left, I take the limit as x goes to 4 from the left of the top formula, x squared minus 4x divided by x squared minus 3x minus 4. I try to apply the direct substitution property. I plug in 4. When I do that, I get 0 in the numerator, and I also get 0 in the denominator. That gives me an indeterminate form, which means I have to apply some algebraic manipulations first to compute this limit. I recorded a video about computing limits algebraically. I will add a link to that video in the description of this video. Now, to compute this limit, I will factor the numerator. I see both terms in the numerator have x in them, so I will factor x out of both of the terms. In the denominator, I will also factor that polynomial, and I will get x minus 4, x plus 1. I see now that in the numerator and in the denominator, I have factor of x minus 4, so I divide it out, and I get the limit as x goes to 4 from the left of x divided by x plus 1. Now I will apply the direct substitution property. I plug in 4 to the expression, and I get 4 divided by 5. So the limit from the left of this function is 4 divided by 5. To compute the limit from the right, I am going to use x's, the inputs that are bigger than 4. So I'm using the formula for x is bigger than 4. And I get the limit as x goes to 4 from the right of square root of 5 minus x minus 1 divided by 4 minus x. I try to apply the direct substitution property. If I plug in 4 to the numerator, I get 0. Plug in 4 to the denominator, I get 0. This means it's of the form 0 divided by 0. It's an indeterminate form. I must apply some algebraic manipulations. The algebraic manipulation I'm going to use here is called multiplication by the conjugate. I multiply both the numerator and the denominator by the conjugate of the numerator, which is the same expression as the numerator, but with a plus sign between the two terms instead of a minus sign. So I get 5 minus x plus 1 divided by square root of 5 minus x plus 1. If you're not familiar with this algebraic manipulation, I suggest you watch my previous video about algebraic manipulations and computing limits algebraically. Now, this is a minus b, this is a plus b, so I use the formula a minus b multiplied by a plus b equals a squared minus b squared. So now, when I multiply these two, I get the first term squared minus the second term squared. And I get the limit as x goes to 4 from the right side of 5 minus x. That's what I get when I square the square root. Squaring 1 gives me 1, so I get minus 1 divided by 4 minus x multiplied by the second denominator, square root of 5 minus x plus 1. In the numerator, I have 5 minus 1, that gives me 4. So I have, in the numerator, 4 minus x. In the denominator, I also have 4 minus x. So I can divide those out. And I will get the limit as x goes to 4 from the right of 1 divided by square root of 5 minus x plus 1. Plugging in 4 will not result in dividing by 0 anymore. So I get 1 divided by square root of 5 minus 4 plus 1. 5 minus 4 is 1, square root of 1 is 1, so that is 1/2. We just found that the limit of this function from the left is 4/5. The limit from the right is 1/2. These two numbers are not the same, so the overall limit of this function as x approaches 4 does not exist.